Hi guys, welcome back to my YouTube channel. Today in this video, we're going to learn about what is sliding window protocol and how it works, and also we can see a 1-bit protocol and some communication networks at all. Come guys, let us start the video. These are the contents covered in this video guys. First one, communication. Communication is nothing but the data communication between hardware and user. There will be a seven layers of ISO model. First one is physical layer. Physical layer is responsible for establishing a connection between reader and sender. Only physical layer had access to communicate or connect with hardware particles or hardware devices. And the next one is data link layer. Data link layer is mainly responsible for detection of errors in a transmission media. And the network layer, it is also responsible to route the data to correct destination. Nothing but where the data need to transfer or where the destination of data to be sent. This will be decided by network layer. Transport layer. Transport layer is nothing but it decides whether the data is used through parallel mode or serial mode. Parallel mode is nothing but simultaneously sending the packets or data. But what about serial mode? Nothing but we need to send the packets one after another. And next one is session layer. It will check how active the user interacting the session. If the user is not interacting, the session should be expired after some period. Like if you know about internet banking and all, it will have a logout time session. Nothing but if you are logged in and you are not used anything till 5 minutes or 10 minutes, then automatically it will log out from the internet banking system. Nothing but it has a session out after 5 minutes or after 10 minutes, like that. And the next layer is presentation layer, which converts the data into user understandable format, and it will be present the data to the required receiver end. And the last layer is application layer. It is responsible for providing permissions or GUI interface to the user. This is all about 7 layers of OSM model guys. And next one, sliding window protocol. Sliding window algorithm, a method of flow control for network data transfer. Data link layer uses a sliding window algorithm which allows a sender to have more than one acknowledgement packets in flight at a time, which improves a network throughout or throughput. Key concepts of the sliding window protocol. Protocol is nothing but some rules and regulations. Both the sender and receiver maintains a finite size of buffer to hold outgoing and incoming packets from the other side. Every packet sent by a sender must be acknowledged by the receiver. The sender maintains a timer for every packet sent, and any packets unacknowledged, then in the certain time it will be resent. The sender may send a whole window of pockets before sending a acknowledgement. For the first pocket in the window, this result is a high transfer rate, and as a sender may send multiple pockets without waiting for each packet acknowledgement. The receiver advertises a window size that tells the sender how much data is it can receive. In order for the sender not to fill up the receiver buffer efficiency can be also be improved by making uses of full duplex line is nothing but the data is transferred from receiver to sender to receiver end, and receiver to sender end simultaneously. Piggy bank. When a data frame arrives, Instead of immediately sending a separate control frames, the receiver restra- the receiver restrains itself and wait until the network layer passes it to the next packet. The acknowledgement in attached to the outgoing data frame, it is known as using an acknowledgement field in a frame header. The acknowledgement gets a free ride on the next outgoing data frames. The technique of temporarily delaying outgoing acknowledgement so they can be hooked into the next outgoing data frame in piggy bank. Since the sequence number to be used occupied a field in the frame, it should be limited size. If the header of the frame known as k bits, the sequence number arranged are range from 0 to 2 minus 1. I'm sorry, 2 per I minus 1. Sender maintains a list of sequence numbers that it is allowed to send or sender window. The size of sender window is at most 2 power I minus 1. Example, if frame allows 3 bits, then the size of a window is 2 power I minus 1, that's equal to 7. Nothing but 2 power 3. We have 3 bits here, so that 2 power 3 minus 1 equal to 7. This is the size of a window. The sender is provided with a buffer equal to the window size. Receiver side. The receiver allows maintaining window size as 1. The receiver acknowledges a frame by sending an acknowledgement frame that includes the sequence number of the next frame, the frame expected. This also explicitly announces that it is preferred as receiver the next n frames are beginning with a number specified like that. This scheme can be used to acknowledge multiple frames. It could receive frames 2, 3, 4, but withholds the acknowledgement until frame 4 has arrived. By returning an acknowledgement with sequence number 5, it acknowledges frame 2, frame 3 and frame 4 at one time. The receiver need a buffer of size 1 where the data has been stored, that is called a buffer. 1 bit sliding window. Here k equal to 1 at the sender side, then the size of a sender window is 2 power k minus 1, and we have a k equal to 1 here, and that's nothing but 2 power 1 minus 1, nothing but 2 minus 1, that is equal to 1. This is same as the stop and wait protocol. You know about stop and wait protocol previously, I think. It's nothing but only in a stop and wait protocol, only one data or one frame can be transferred from sender to receiver. After getting an acknowledgement from receiver end, then only another data or another frame will be transferred from sender to receiver. This is all about stop and wait protocol. We can see here sender and receiver end. In a sender, it is ready to send first unit like 0. The receiver is waiting for getting a output called 0, or you need to receive the data from 0 to 1. And in a second image you can see that the sender already sent a data, but the receiver doesn't receive the data till it is asking for a 0 itself. In the next stage, the sender sends a next data from 1 to 2, or nothing but 1 data 1. The receiver receives the data 1, and the next stage it is ready to send next data, and the process will be going on like this. 1 bit sliding window protocol. In this, we are going to acknowledge that if a contains some values, a sends 0, 1, a0. It is acknowledged by like we have taken as a reference like B gets from A to B gets 0 as an index and 1 and A0 address. It is incremented, 1 will be acknowledged as 0 because of it is acknowledging value, so that it will sends an acknowledgement. B sends an acknowledgement to A that gets A 0 comma 0 comma B0, whatever acknowledgement they send. Then the index is incremented, then A sends 1 comma 0 comma A. 0 is an acknowledgement what it gets, and it will transfer the next input, so that it will transfer data, it will transfer the frame. Then B gets 1 comma 0 comma A1. The process will be going on throughout the end. In this image we have used that notations called SCQ, acknowledgement ACK, and packet numbers sequences. Merits: multiple packets can be transmitted without waiting for acknowledgement, not like stop and wait, but piggy banking using full duplex lines. You already know about full duplex lines. These are the communications. One is simplex, another one is off duplex, and last one is full duplex. Simplex is nothing but we can transfer. You can transfer a data, and in off duplex we can transfer a data. We will get a acknowledgement. In full duplex we can simultaneously transfer a data. Nothing but from sender to receiver we can transfer data, and we can also receive the data at the same time. It is known as full duplex lines. Demerits are no limit of size or sequence numbers that can be required in a protocol. The bandwidth may be wasted in some special situations. Thank you guys. This is all about our video today. Thank you guys. See you.